Welcome, everybody, and welcome back to, excuse me, to the Breyer Center for Overseas Studies in Florence of Stanford University. For those of you who might not know me, my name is Linda Campani. It's actually Ermelinda Campani. I'm the director of this program, and I have the pleasure and the honor tonight to host this event. It's one of our recurring events that we host with Friends of Florence, an extraordinary association about which I'm going to tell you a little bit. After I speak a little bit about Friends of Florence, the president of Friends of Florence, Countess Simonetta Brandolini d'Adda, will then introduce our speaker, Professor Bill Wallace. Welcome back to Stanford.
Thank you.
Countess Simonetta Brandolini d'Adda founded Friends of Florence in 1998. As their mission statement reads, the foundation is dedicated to preserving and enhancing the cultural and historical integrity of the arts in and around Florence through restoration projects and educational events. The foundation's first major project was the restoration of the Loggia dei Lanzi in Piazza della Signoria. That happened in 2002. They then restored the 22 paintings which keep company to the David in the Galleria dell'Accademia. They also funded all of the diagnostic analysis for the restoration of the David himself when he turned 500 years old. Other restorations projects include the Niobe room in the Uffizi Extraordinary, the Tribune in the Uffizi Gallery again. They worked on Ghiberti's Gates of Paradise. Currently, they're doing all kinds of projects, including one which I think is absolutely wonderful, the Chiostrino dei Voti in Santissima Annunziata. If you have not been, go, or especially go after the restoration will be completed. I was now looking through the website of the Salone dell'Arte del Restauro, which opens tomorrow, and I read that Friends of Florence has made available a grant for 20,000 euros, special prize for a young restorer with a project and a plan and the skill to conduct that restoration. So it's a true pleasure for Stanford University, which has been here in Florence for the last 50 years with this program, to co-organize events with Friends of Florence who are truly sincere and good friends of the city and of the art that the city has to offer. So thank you, Simonetta, and please come here with me.
Thank you. It's always an honor and a true pleasure to be here at Stanford, and thank you, Linda. It's always, I think, such an interesting part of any week that when one can sit down here in this beautiful room and enjoy a great lecture, as I'm sure this evening's will be. I'll just tell you a little bit about William Wallace, which I'll call you Bill. Received his PhD in art history from Columbia University in New York in 1983. And that same year joined the faculty of Washington University in St. Louis. He is the inaugural holder of the Barbara Murphy Bryant Distinguished Professor of Art History in the Department of Art History and Archaeology since 2003. And Professor Wallace is an internationally recognized authority on the Renaissance artist, architect, and poet Michelangelo Buonarroti. Professor Wallace has published extensively on Renaissance art, in addition to more than 80 articles and essays, including 2 short works of fiction, which I didn't know about. He is the author or editor of 7 different books on Michelangelo, including the award-winning Michelangelo, the Complete Sculpture, Painting, and Architecture of 1998, Michelangelo at San Lorenzo, The Genius as Entrepreneur in 1994, and most recently Discovering Michelangelo in 2012. His biography of the artist, and which I personally recommend, Discovering Michelangelo, was published by Cambridge University Press in 2010, and it's just recently come out in paperback. He is a recipient of numerous awards and fellowships, including a year spent at Abilitati, Harvard University's Center for Renaissance Studies in Florence, and a year at the American Academy in Rome. He's been a principal consultant for 2 BBC television programs on Michelangelo and has taped a 36-lecture audiovisual course, The Genius of Michelangelo, for the Teaching Company. This semester, he is a visiting professor at Abilitati, where he's completing a book on Michelangelo's late life and art. And we just had a wonderful opportunity to go through Italy, actually, with Bill and also with his lovely wife, Beth, following the trail of Caravaggio. So we traveled in October from Florence to Rome to Naples. After Naples, we went to Sicily and went to Syracuse and then on to Messina and Palermo. All of us completely passionate about Caravaggio, thinking that we are all experts. The real expert is Bill Wallace, but we became experts in our own right, at least in our own minds we did. Next year, Bill will be leading a program actually connected to the Chiostro of Devoti and Santissima Annunziata on Michelangelo and the Florentine Manurists in June. And if anybody wants to know about our programs, you can just go on our website, Friends of Florence. But 2 years ago, it actually was 2013, we had the true pleasure of having a program on Michelangelo with Bill. And that was between Florence and Rome. And I must say, it was just an enlightening week together with him. Without further ado, I'd like to introduce Bill Wallace, and I hope you enjoy his lecture.
Thank you, Steve, and thank you all for coming on a sort of nasty night to hear a little bit about Michelangelo. My title is purposely provocative because I think we all recognize that Michelangelo is a great artist, but we don't generally put him in the category of the greatest engineer of the Renaissance. And I think if we think about who are the great engineers of the Renaissance, I think the names that immediately come to mind are Brunelleschi and Leonardo da Vinci. I'd like to claim, though, that Michelangelo is actually the greater engineer because he actually did something. Leonardo thought of a lot of things and did nothing, but Michelangelo actually carried things out. And so I'd like to try and run through some examples of Michelangelo as an engineer, and then actually talk about two projects in particular, the David and the building of San Lorenzo, as examples of how engineering has actually affected the way the work of art looks. So it's not just that he's a great engineer, but it's actually part of the art that he actually ended up making. So immediately we'll try and start, if we can advance here. We naturally think of Brunelleschi as a great Renaissance engineer, and Brunelleschi did build a dome, but of course the only other person in the Renaissance to build a dome was Michelangelo. And he did it, at St. Peter's and built a fabulous dome on the model of Brunelleschi's dome. So Leonardo never built a dome. But Leonardo, as you know, we have some 6,000 pages of Leonardo's notebooks, and he thought about a lot of things, but he actually carried out almost none of them, including the horse, the great horse he was meant to, and this is advancing very slowly. What's that? Is the other one? Let's try two of them at once. There we go.
It has to be pointed.
Right at it. Just an example of Leonardo's drawings, which are fabulous and fascinating and absolutely, incredible, but some of them are absolutely ridiculous too. I mean, the idea of building an entire machine to make files, for example, on the right-hand side. Or in many cases, Leonardo's ideas were far outrunning the engineering and the materials of his day. And so, despite the fact that Leonardo's machines are on exhibition in every single city in Italy, none of them were ever built in his lifetime. Those were all built subsequently. So I'd like to talk about Michelangelo's. I couldn't be pointing any more directly at this machine.
I'm going to come into it for you.
Really?
Yeah.
Okay. So let's start early in his career with the Sistine Chapel, and we could have the next, please.
Yeah.
Immediately on the completion, or even at the beginning of the conservation of the Sistine ceiling back in 1980, was the discovery of the fact that Michelangelo had developed a brilliant solution to how to paint the ceiling. For up until that moment, we had thought of numerous possibilities of how he had built a scaffold in order to reach the ceiling. And for the most part, people imagined a large tower going up in the middle of the chapel, which of course would have interrupted all kinds of uses of the chapel, which never happened. The chapel was a continuous use all through the time. And other people imagined, as Bramante suggested, that we hang ropes from the ceiling and have a scaffold But imagine a scaffolding hanging from ropes and move around a little bit too much. And then what do you do once you're done and the holes are all over the ceiling? So what we found, what was found at the very beginning of the conservation was that Michelangelo had developed this enormously intelligent kind of bridge running on trade rails, essentially, that he put on the side of the chapel. This would have been constructed out of wood and rope rather than now out of wood and metal. But a scaffold that could then only cover part of the ceiling and actually be moved along and never interrupt the work in the chapel itself. So we have something that looks like this. Skip to like that. So that, and not only is the bridge sort of a brilliant solution to painting the ceiling, but we immediately realized that Michelangelo never at any point had to lie on his back. For the most part, he was standing on steps and facing the curve of the ceiling almost directly, except only at the very, very midpoint of the ceiling would he have had to be working directly over his head very uncomfortably. So really, an incredibly simple but brilliant solution to an obvious problem. So in the field of engineering that really was terribly important in the Renaissance, which was military engineering, here too we tend to think of Leonardo as the great military engineer. And yes, we have hundreds and hundreds of drawings of Leonardo's machineries for military mechanisms, but who in the Renaissance is going to build an overly large crossbow? Crossbows are no longer part of modern warfare, and nor are walls of a medieval high sword like Leonardo imagines here on this drawing on here. Instead, Michelangelo also has a group of drawings, and he was responsible for the defense of Florence in the years 1529, and he actually not only designed a number of very interesting fortification drawings, but they were actually built. They were built and they successfully defended Florence for 10 months. None of Leonardo's fortification designs were ever realized in reality, but Michelangelo's were, even if his drawings were somewhat complicated in their initial ideas when they became built, they were sort of simplified, but the real essence of Michelangelo's idea was this angled bastion, very low, very slanted, what we call battered walls, because he's thinking about the modern development of cannon warfare, which has revolutionized and changed the way the cities are defended. This kind of angled bastion continues for the next 400 or 500 years, right down to the American Civil War, still defending fortifications in the same way, and right down to the World War I Maginot Line. It's not until the German Blitzkrieg made this completely irrelevant. But Michelangelo has a very large role to play in the history of military and fortification design. So those are a couple of examples. Let me think about two larger examples and how engineering really does affect how a work of art looks. And let's start with a very obvious example, like the David. The David doesn't really look like a religious figure. It really doesn't look like a David. He's supposed to be a small shepherd boy, and instead he's a giant, naked giant. So let's think about how engineering actually affected the way that Michelangelo imagined and carved this figure. The first thing we should recognize is that Michelangelo succeeded where everybody else had failed. This is a block that had been quarried 40 years before. 3 other artists had tried to carve it into a figure. It was always destined to decorate the cathedral. It was owned by the cathedral. It had been transported to Florence as a part of the decoration of the cathedral. And it's about the size of that block that we see up on the upper side. So the first thing we have to admire is that Michelangelo got a figure out of this block at all, because most people had decided it was a ruined thing, that it was no longer capable of being carved into a figure. And of course, Michelangelo, the young 25-year-old, said, I can do it, give me the block and I'll do it. But the answer is, once it's carved, it's destined for the cathedral, and it's supposed to go there. And my question is this an impossible task? I think it is an impossible task to put that figure up on the cathedral, and I think Michelangelo knew it from the very beginning. And the fact that he knew it, in a sense, liberated him and allowed him to carve what he wanted rather than what the cathedral wanted. Because the cathedral could never really want a 17-foot high naked boy on the cathedral. It just makes not a real lot of sense. So let's start with the weighing of the David. How much does the David weigh? Good guess. Good guess. Let's go next. We have numbers of copies of David's, including the one that was made in the 19th century here in Florence, but a recent one in Pietrasanta was sent to a bank in Brazil. But again, this is a figure that's so large, nobody actually puts it on a scale. There is no scale to weigh sculpture, especially of this size. So even these people in Pietrasanta are only estimating its weight in order to pay shipping costs and things like that, and to figure out the pulley system needed to lift it. They underestimate this by about a ton. It's 7.5 tons, they think. But it's not until Stanford University got into the act that we actually knew how much the David weighed, and more precisely how tall it was. Every book produces a different number for the height of David. And it was not until Stanford University, Mark Lavoie, had a digital scan of the David created in 1999 that we have a precise height of the David and an almost precise measure of the weight. Because you only can, in the digital scan, decide how many cubic feet of marble are involved, and depending on the weight of the individual marble types, you have a slightly different weight. But his answer is 8.5 tons, and that's much closer. So now think about 8.5 tons having to go up here, 60 or so feet above the ground. How do we get it up there, and what is it going to look like when it gets there? Well, the problem really is that 8.5 tons is a static weight. Once you start lifting it, you measure the weight not in static weight, but by kilonewtons. Don't ask me to go into great detail about a kilonewton, but it has to do with the acceleration of gravity. The higher it goes, the weight gets more and more dangerous. And instead of 8.5 tons, we would measure this as 75 kilonewtons, but if the ropes start swaying, or there's any kind of jerking or stopping of any sort, the kilonewtons go exponentially higher. And it goes something like 75 kilonewtons to 110 kilonewtons, which is a hugely dangerous weight, and one that could not be sustained by any rope manufactured in the Renaissance, or any number of ropes manufactured in the Renaissance. So all of those numbers and those things that are affecting the lifting of an 8.5 ton statue are suggested in this drawing, and fortunately I'll leave it to the Stanford students to understand it all. But let's also think of the apparatus needed to lift that object. Now, back in the Middle Ages, you had all kinds of hoists and things like this on the left-hand side to lift stones, and these are the similar types that Brunelleschi would have used in the building of the cupola. However, all of those medieval cathedrals, for as fascinating and as large and complicated as they are not lifting 8.5 ton stones. They're lifting smaller stones and putting them together to create the cathedrals. And so to imagine the kind of apparatus needed to lift a weight like this, we have the additional problem of torque. That arm that's going to be leading out over the building in order to lift the David is going to be subjected to impossible levels of torque, and you're going to have to create an apparatus so large that it's not going to fit anywhere on the cathedral. There's just no space up there with the dome already constructed to put anything large enough to lift the David. Moreover, the only available space is right over a semi-dome that was not constructed in order to support this kind of undertaking. So let's think of a different way that possibly it could have been done. And we can imagine that a scaffold built alongside the building with the David being lifted vertically, straight up, is another way of doing or overcoming the problems of weight. And this is how the David was lifted off its base in 1910 and taken to the Academia. So this is a gantry kind of crane that lifts the David absolutely vertically and then can move it along a railing, sort of like this. So this is a possibility. So let's think about something like this with the David coming up through the middle. Next, we have to get up to all the way to the height of the buttress, and then we have to move them laterally, which is not going to be an easy task at all. But actually, we're going to have to reinforce that scaffolding. This is going to take all the wood in Tuscany to build this scaffolding in order to construct this David. Moreover, we're not absolutely sure that that buttress can support 8.5 tons by any means. In 2010, however, a fiberglass copy of the David was lifted to the buttress to see. Some of us were here to see this. Now, it was lifted to the buttress using a the typical way that Italians move furniture in and out of tall buildings with very narrow staircases. This kind of group could probably lift the David, but the fiberglass was quite a bit lighter. And you notice that even for the fiberglass, they had to build a little scaffold underneath it because really the buttress wasn't designed in order to support this kind of figure. And the upshot of all of this is that the David in that place looks ridiculous, terrible, and it only lasted a day. They got it down really quickly. So, I would like to suggest to you that Michelangelo knew from the beginning, because he was enough informed of it as an engineer, that it was never going to be lifted to that buttress. And it, in a sense, liberated him to create what he created, which is a stunning work of art that really isn't rational or reasonable, it's not narrative, it's not immediately identifiable, it's only recognizable because it's so familiar to us. But you could never imagine carving a David that looks like that if you were following the Bible, for example. So what Michelangelo did instead was carve a gigantic work of art. There was not going to be a secondary decoration for the cathedral, but instead was going to declare that he was the greatest sculptor of all time. And from this moment, from 25 years old on, 26 at this point, he is the greatest artist, the greatest sculptor, and he never is out of work ever again. And any artist who's never out of work for the rest of their life should do something of the same thing. So this is, I think, where Michelangelo's sense of engineering allowed him to have the freedom to carve something that was radically new and original, and really established himself and his career. The other project I'd like to talk about is the building of San Lorenzo. 16 years that he worked at San Lorenzo, designing a facade for this church that he imagines to be entirely made out of marble. There is no marble in Florence. The closest sources of marble are the Carrara and Pietrasanta Quarry is about 90 miles away, but even longer if you actually follow the course of the marble. So here we have a gigantic project, and for this project, Michelangelo designed this wood model, which still exists in the Casa Montrotti, a very impressive wood model. The first purpose of the wood model is to convince the patron to spend 40,000 ducats on this project. Now, 40,000 ducats, the whole church probably costs about 25,000. So the facade is costing 40,000 ducats. So some patron needs to be convinced that this is going to be the most spectacular facade in all of Florence. And I think Michelangelo knew that he was setting out to do the most spectacular architectural project of his life. The other reason to have the model is that we have to have a very careful plan of how much material we need, because the transport cost is always 10 times the cost of the material itself. So every block of marble, if it costs a ducat to quarry it, costs 10 ducats to transport it, and that's just an example of 10 times the cost. So Michelangelo has to be very careful to know precisely how many blocks and what size he needs in order to carry out this facade, because the majority of the cost here is going to be in transporting the blocks 90 miles. So the model tells him, for example, it needs 12 of this size, and he needs 24 of these, and he needs 12 of these. And these are the ones we want to concentrate on, because his main plan for the facade was to have 12 monolithic columns, one for each of the apostles. 12 monolithic columns of 20 to 22 feet high, that is single blocks of stone. Michelangelo is quarrying and transporting the largest blocks of marble since Roman antiquity, more than 1,000 years before, with as much logistical complexity as the Roman Empire. But of course, we don't have the Roman Empire nor slave labor anymore. Michelangelo is doing this all himself. So he spends, in the 3 years between 15, 16, 19, he goes to quarries more than 30 times. Every red line is him going there and back in 3 days in order to organize the logistical system of the quarrying, finding the marble, and setting up the transport system in order to bring it the 90 miles from the quarries all the way down to Pisa and up the Arno River to Florence. So, he spends a lot of time in Carrara and Pietrasanta, these two places where he found most of the marble that he needed for the facade. In about 4 years, he quarried and transported about 2,000 blocks of marble, which is on almost an industrial scale, and nothing had been done like that since, as I said, the Roman times. So the main problem was those columns, And so it's not a surprise that one of the first things Michelangelo does is draw exactly what the column is and its dimensions. But alongside, because these drawings are being given to quarrymen in about 10 different locations on the mountains around Carrara and Pietrasanta, they're not talking to each other, and they're all using different measures. The measure in Florence is the braccia, 58.36. But the braccia in Pisa is a different measure. It's a different length. So Michelangelo draws on the page here exactly, this is the braccia fiorentino. And everybody in the quarry is going to use my braccia. And so my columns come out the right size. So you want to have, and you're going to have, columns 20 to 22 feet high, which are longer than anything in this bed of marble we're looking at. But moreover, Michelangelo was a stickler for materials. He wanted only the best. Not only the purest marble, but absolutely no blemishes, no veins, no nothing, pure white. So he doesn't find them in the nice, convenient, low quarries, but finds them up there. If Michelangelo can make it even more difficult, he always did. You could have the next. So that hole, that quarry, is there on the mountain, and we're looking at the nearest village of the quarrymen. They didn't just go up there every day, they went up there for a week or 2 weeks, and they would live up on the mountains and then quarry and then come back home. But actually, there's another, kind of the next higher one. And that was really where Michelangelo found most of his marble. And it was such good quality marble, even though in its hugely inaccessible location, that through the 19th century it continued to be quarried until they went right through the mountain, quarried right through the vein. And so the evidence of Michelangelo's presence is a little bit lost because the quarry was, the marble was so good that it was continuously quarried ever since. And now just a little film about that process, which is enormously dangerous. And even today, 1 or 2 people have serious injuries or deaths every year up in the quarries. And look at this man's fingers. He's lost the fingertips on both of his middle fingers. One of the most common injuries, ropes or wires cutting the fingers. So many of the quarrymen up there have various injuries, but they're enormously proud of this Mestier. This is all purposely detritus that is put there precisely to soften the fall of the block so it doesn't fracture, because marble is a beautifully crystalline structure and it fragments very easily along lines. So what they're breaking off now is about the size of the Michelangelo column. It's just a larger block in terms of thickness than Michelangelo ever did, and he didn't have one of these. He would have done it by putting wedges into the grooves here and wetting the wedges until it's split, and then literally push it apart manually. It's beautiful stuff. That's about the height of one of his columns. But he doesn't want any veins, no veins, pure white. And I think next. So the technique of doing this up until modern times was very traditional, since unchanged really since Egyptian times into the late 19th century, when the men are doing precisely that. They're driving either metal or wood wedges into cracks that have been created, or natural cracks, and then wetting the wedges in order to split, and the marble will split along very nice and neat lines like this. But a very laborious and a very dangerous process, and especially because once you've quarried the marble, you have to get it down the mountain. And getting it down the mountain is like looking down to the sea here next. And that is a process called vizzatura, which is bringing down marble blocks on marble boats using ropes. And Michelangelo spent a lot of time worrying about rope. The quality of rope mattered, life and death. Twice the ropes or rings, that forged rings, broke on him. And not only did he lose one of his marble quarrymen, but at one point he almost lost his own life. And inevitably you lose the block of marble. It falls down the mountain. We have these enormously pointed letters of Michelangelo writing about yes, my worker died today, but I lost 6 months of work because the block went down the mountain. So this is a process that was still being undertaken in the 19th century. We use now large-scale trucks with 22 gears to carry out the same process, but you can see just how dangerous this is and how still it's a very dangerous profession even today. They reenact the bringing down of these marble blocks every year up in Pietrasanta. It's really quite fascinating, but fascinating to watch. This is one of the paths that Michelangelo had to construct himself in order to bring down those blocks from that high, inaccessible quarry that I showed you before. And these are rope burns in the rock. And you can just feel the tension of those blocks coming around the corner and the danger on your fingers and on the danger altogether. Once you're down from the mountain, you have to then be transported, that is, lift the block onto a cart somehow, build some kind of hoist, and then pay these guys to drag it from there, which is where we were up on the mountains, all the way to the sea. And because this was a very marshy land, and because Michelangelo was quarrying blocks larger than anybody else had quarried before, they were sinking into the marsh. He had to build a road. So he became a road builder. And then when you get to the sea, he had to figure out how to lift it. He had to build what he called a capocavallo to lift the blocks from the side and onto the boat. He had to go to Genoa to find boats large enough to transport his large blocks from Pisa up the river to Arno. And then at one point the capocavallo broke, the block fell down, went right through the boat, sank the boat. Again, he lost 3 or 4 months of his work because he had to start over again. Now it's 2 to 6 months between the time the block is quarried in the mountains and the time it arrives in Florence. So every single block that comes down to the marina and is ready to be shipped, Michelangelo draws them in stereometric drawings. He's one of the first artists to use stereometric drawing, three-dimensional drawing of three-dimensional surfaces. And he gives the measurements of each one. And he then has a notary come along and say, yep, that block is this block, that block is this block, and sign it. That's what the notary is doing here, so that 6 months later, Michelangelo can prove that I'm missing 2 of these blocks, or these are my blocks that have been transported from the quarries to Florence. For example, this is the block that created the Giuliano de' Medici statue. Now, granted, Michelangelo is thinking about what Giuliano is going to look like already. He wants a seated figure, and he's sort of going to have the block roughed out in the quarries, approximately to that shape. But in some ways, he's still subject to the materials and what he can do with the materials and what happens to the materials between the time it goes in the quarries and the time it comes to him. So whatever thinking he does ahead of time is going to be governed or constrained in part by what happens when he's actually got the marble in the studio and begins to quarry or carve it. So meanwhile, Michelangelo's back in Florence and he's building the Medici chapel and he's carving those figures, but he has a lot of people working with him, carving marble, beautiful marble architecture that helps decorate the chapel. But at the same time, the chapel has a lot of other kind of stone. This kind of stone, pietra serena, which is all over Florence. This is the local stone of Florence. And it shades from gray to green. Again, Michelangelo wanted pietra serena of the purest kind. And so, if you think about how much pietra serena, for example, is in the Florentine Library vestibule, here too, Michelangelo is dealing with a huge amount of material, and again, with monolithic columns, because the facade was never actually built, but instead of 12 marble columns, we're going to have 24 pietra serena columns of 20 to 22 feet high. And they are put not on a ground floor, but on the third floor, equivalent to the third floor, and has to be lifted through an already existing church courtyard into a very, very, very narrow space. And a huge amount of this pietra serena, which comes from quarries all around here in Florence. The Cave di Maiano are very, very famous, but that whole mountain is really pietra serena. Again, Michelangelo is organizing the entire logistics of the production of the quarrymen, organizing teams, and the production of the material into the stone that he needs. And again, he's most concerned about those columns because they're the biggest blocks that have to be moved into the center of Florence and then raised up into this very, very narrow vestibule, so that every time a quarryman finds a block that's really the size of one of Michelangelo's columns, he's very happy, he stars it. make sure that Michelangelo recognizes in my account book, I got one of the columns, you better pay me, you better very well for it. And these caves, again, have been excavated ever since Michelangelo's time, and almost excavated out now. Pietra's terrain is sort of at a premium, no longer in Florence, but many of these still survive around the hills of Florence, where Michelangelo worked. But I'd like you to think about the case of, he had now, just like in the facade, but now on the interior of the building, he's building the Laurentian Library, he has to coordinate the delivery of materials and the use of materials. So a huge number of workers, but they have to have enough material to work, and they have to have space to work, and he has to coordinate the delivery of, as we show here, the bases of the columns, and then the column shafts, and then the capital. So he's, in a sense, going right up, and he's thinking about the delivery of the material in order that he's building, and he has it all worked out so that the system of delivery and the system of working at the work site and the system of putting it into place are all brilliantly coordinated so that he actually was able to put 6 of these columns into place in the space of 2 weeks, which is an engineering accomplishment that would be pretty much admired, I think, even today. And of course, this takes a lot of help and a lot of workers, and one of the great myths of Michelangelo is that he did everything alone, but he never built architecture this way. So this is one of his many, many lists. He kept track of every one of his workers and knew every one of them by name, kept his own list, and a year later, he had 110 people working for him because it was getting to be a very complicated operation, and he was in charge of it all, which we see from this kind of design. Michelangelo's at the center, and what we can learn from a diagram like this is that according to today's business practices, Michelangelo is not an efficient businessman. An efficient business model would be pyramidal rather than horizontal. But what the horizontal shows us is that Michelangelo was in charge of every facet of the building project. Everything down below here is the things that are being done. Everything above there is the money that's coming in and the patrons who are telling him what to do. And he's at the center of the entire operation. And he has a sense of that entire operation and a knowledge about every detail of that operation, which is extraordinary. So I'd like you to think that the next time you're in the Medici Chapel and admiring the great figures of Michelangelo, that he accomplishes more than just carving fabulous marble figures, given that his engineering and carving is rather primitive. This is his only materials, engineering-wise, to carve all of that stuff that we see and admire today. Thank you very much.